Hey, good morning, everyone.
Hello, good morning.
Good morning. We'll start in just a minute or so. Okay. Let other people join in and then we'll start. Maybe we'll start at say 9:03 or 9:04. Meanwhile, if you have anything to discuss, more than welcome. Okay, we have now two people. Let's wait for another two more minutes. Meanwhile, if you guys
Sure.
have anything to discuss, just let me know. If you want to
Yeah,
discuss, yes.
and first of all, I just want to know like how your name pronounced. It is Sanatan, right?
Sure, sure. Yes, you can call me anything. That's fine.
No,
Sanatan.
no, no. Like
Sanatan
I just want
is fine.
to confirm it. Yeah,
Yeah, it's Sanatan.
yeah. Sanatan, it's about we have been assigned in capstone for YouTube harvesting. So actually, when I'm trying to do that, I can able to get the details. Like I'm harvesting the data through the API key to store in MongoDB. I can through the variables or by storing into pandas, then I can do it. Or can I get any insight about?
It's no. It's your call. You can store it in any type of database, be it MongoDB or say MS SQL or MySQL,
Okay.
even Postgres. Anything is fine as long as you are comfortable with it. Now,
Okay.
you just need to learn like how to integrate that database with the API that you will need to deploy it.
Okay. Okay.
Right. For example, let's say if you have been using Streamlit or Flask, any specific thing has been mentioned. See, I'm not the mentor for that, and
Okay.
I don't really know all the details. So
Okay.
I'm asking like, what API are you going to use for your model deployment? Is it Streamlit, Flask?
Yeah, I'm using in the capstone itself, they've suggested to use a Streamlit, and
Okay.
I'm also using the Streamlit.
Okay. So I think better to use MongoDB. You can also
Okay.
use MS SQL as a substitute or MySQL as a substitute. MySQL would be easier. I mean, as you would know, my SQL is much easier than
Yeah.
using no SQL, right?
Yeah, actually, the project, how it goes now, I have to get 10 channels information and
Correct.
store it into MongoDB as a lake, and then I need to migrate the data to the SQL, and from SQL, I need to visualize what are all the things I have, like the way it goes.
Yes. So
Yeah.
these are the essential steps, basically, what you described.
Sure.
Okay. So in case you get stuck, we can then discuss more about it. Okay.
Yeah.
All
Get
right.
it.
In probably in a doubt clarification class.
Okay.
Right. Because I mean, see, we are currently in the lecture sessions, so I'm not discouraging it, but
Okay.
since we have time right now, we can discuss it. But
Sure.
like for your doubts related to projects and all, it would be better if we discuss it with the respective mentors. I'll be happy to take it up as if I were one of your mentors.
Okay.
Because
Get
I
it.
really don't know the specific details about this project.
Mm-hmm.
I can tell you maybe some extra details or extra things that
Totally.
you may want to know for implementing it. So if you're getting stuck, show me the code and I'll help you with that.
Sure.
Okay, I can help with that for sure. Okay. All right. So hi everyone. My name is Sanatan Sukhija. I'll be teaching you guys the following topics. So basically machine learning and NLP. So these are 2 topics that I'll cover, and they would take probably 14 lectures, okay, in total. That's what I believe. Okay, so 14 lectures, 14 to 16, let's say. Okay, so 14 to 16 lectures in total. So approximately 4 weeks. Okay, approximately 4 weeks. Now, before I get started, I have a few questions, and like after getting the clarification from you guys, I'll be able to set up a nice space according to what you guys want. So I want a like a majority from you guys about like how would you prefer like if you would prefer, let's say, theory plus implementation, or if you want me to stress more on the implementation, less on the theory, or more on the theory or less on the implementation. So see, ML is highly mathematical. Okay, I'll be honest with you guys. This is one of those things. If you want to study in detail, there is no limit to it. So do you want me to be highly mathematical and obviously have a balance of theory, balance of implementation as well? Do you want me to be focused more on the implementation aspect and less on the theory, or the other way around? What would you prefer?
We would prefer rather practical, like which is applicable and for
Okay. All right. Okay. So one person, according to this person, let's go with. I mean, I'll incline myself more on the implementation side. How about others?
I do believe in implementing. Like if we were implementing, however, we'll get more knowledge about it, right?
Sure. So this actually raises one concern from my side. So I will make it clear beforehand. For those of you who are not in a job right now, okay, and let's say you're looking to transition into this area, in that case, cracking the interviews would be tough. Let me tell you why. Because as you would see, like when we start discussing, you would feel that like during the interviews, less questions on the implementation would be asked, because implementation can be done by anyone. I would say the crux is, or the differentiator is, how are you implementing it? When I say that, okay, see, there are a lot of details which I'll have to skip if I focus more on the implementation side. And those details are something which an interviewer would ask you. So let me just give you an example. So if you think about, say, sorting techniques, all right, so maybe say this is an interview question for all of you. So let me see, okay, how much you guys know about sorting. So if anyone is from the computer science side, or say IT side, who has been using sorting algorithms. So my question is to you, okay, let's say I give you a list where you have some numbers, and these numbers are not sorted, okay, they are just n numbers that I have given you. Any number, you can imagine it's an integer, okay, or a real number, that's also fine. So any number is a real number, they are not sorted, okay. If I reduce the domain, let's say, so okay, let's first talk about real numbers. So if it's real numbers, can you tell me what is the best performing algorithm that you guys know? At least the name of it. From the perspective of time complexity, which algorithm do you know works most efficiently? I mean, in the limited amount of time, requires less complexity. Maybe space complexity is also little. Okay, or you can tell me which algorithms you know, at least those.
Bubble sort, binary sort.
Binary sort is not a technique as far as I know. Bubble sort is one of the techniques. Binary search is a technique, but that's a searching technique. Okay, bubble sort is one, but it is not the fastest one in general. Okay, so
Sort.
which one?
Heap sort.
Heap sort is one which would be reliable here, but heap sort would require additional space complexity. Okay, heap sort is perfectly fine here. Okay, it's a very fast algorithm, but requires additional space. Anything else comes to mind? It depends on how you implement the heap. Okay, it depends on how you implement the heap. You can implement it in place and out of place. Quicksort is one. I would say that the best answer to this is quicksort, even though some may argue that the worst case complexity of quicksort is order n square. But the probability that you encounter a worst case is actually very, very little, especially when the number n is large. So the correct answer, in my opinion, for this would be quicksort. Okay, if I were interviewing you, then so the questions would be asked of this type: why is quicksort better? Probably then merge sort or heap sort, which are having almost the same complexity in the average case scenario. So they would dig deeper into it. If you are not aware of the time complexity details, like what are the constants involved with n log n, if you're able to connect with me, especially if you're from the computer science side, you'll be able to relate to this. If you don't know these details, you'll not be able to answer such questions. However, now I'll pose the interview question, and now you think about it. Do you think you can do better if a number is an integer? Okay, and let's say every AI, okay, every AI, it could be, say, 0, 1, and 2. Okay, it cannot be beyond this. So you may have some zeros, you may have some twos, and you may have some ones. I want to sort this list. Can you tell me how would you sort it now? Or would you still prefer heap sort, merge, quick? Anyone who knows about it? Such are the kinds of questions that you will typically face when you apply to tier 1 companies. Okay. So that's why I asked, do you want me to go into those nitty-gritties? Okay, so I'll keep in mind, I'll try to give you a flavor of that as well to some extent, but I'll focus more on the implementation side. Okay. The answer to this is, if you're interested, read about count sort. This is also called as counting sort. Okay, you can read about this count sort. Okay, it's a version of your radix sort. If you're interested, you can read about radix sort. You will understand count sort as well. Okay. Let's start with what is machine learning. Now, okay, would you want me to be interactive, or do you guys prefer to be silent, or I'll just go through it? Or shall I keep interrupting you for more and more questions in between?
Yeah, we
What
want
would you prefer?
interactive.
Yeah, interactive will be fine.
Okay, I'll be very interactive. See, you guys will get bothered. I pose a lot of questions in between, so that way I'll be able to prepare you as well when you appear for your interviews. Okay, so if you want me to be interactive, after a while, if you feel that okay, it is too much, just let me know. Okay.
Yeah, and Sanatan, like you told, right? Like when it goes to the interview and all those, like theory will be very much
It will be
complex
90% important than
correct.
10% implementation.
Okay. So if that's the case, like we all are in here for the job, like however we gonna gain a knowledge, but like if we were looking at what's the goal means, like however it's going to be getting a job, right? So
Right,
if
yeah.
that's the case,
Okay.
case, like we'll go what's good for us, like what good's for our career. Yeah,
Sure. I assumed that you are, I mean, all of you are, because you are in the weekday batch. So most of you are already working. That's what I presumed. And
yeah,
since, like, if you're already working, and see, I don't know the situation, right? So if you want to transition into this area, especially when you are a beginner, or say someone who is going into it the very first time, then they would actually evaluate you very rigorously and more on the theory side. Anyways, I'll try to be precise, and I'll try to ensure that if something is, let's say, not feasible for me to cover, right? Because I told you this domain is so vast. So if something is not feasible for me to cover, I'll tell you what you should, I mean, what you can probably look at. I'll tell you the resource, and then you can cover it in your free time. Okay,
Sure.
I'll share that resource link and other details. See, because there are very trivial things which I cannot cover right now. I hope you understand that. Like, if you want me to cover, say, I hope you can understand. I cannot cover, say, basic matrix multiplication. I cannot cover. I mean, I hope everyone knows how to multiply two matrices. I cannot probably tell you like how to take the inverse of a matrix. If I cover these details, then the session would be. I mean, I need at least 4 to 5 extra sessions just to complete these details, and that is not feasible for you, neither for me. So I'll tell you what to cover in advance also. Okay, from the next class onwards, I'll tell you what to look at so that you are prepared for it. Okay.
Sure.
All right, let's start with this. So machine learning is, I would say, it's nothing but statistics. So as a mathematician, it's nothing but a fancy name given to applied statistics. That's how I find it. Okay, so this is applied statistics only. And what we do in this domain, we do, or you can say, we build models of predictive nature. Okay, so we will be building mathematical models which will estimate. Okay, which will estimate something. What I mean by predictive is they will, you can say, try to figure out something. Okay, what is about to happen, okay, or what will happen. Okay, so we'll use these mathematical models for estimating new things. Now, I'll give you an idea why machine learning is important and what are the scenarios where we need it. So, see, it's a learning paradigm. This machine learning, it's a learning paradigm. If you want to describe it informally, you can say that you want your machines to learn. Okay, this is about making the machines learn for doing stuff of predictive nature. Now, on what kind of stuff machines can learn? Okay, this is what we have to discuss. Or what type of scenarios are there in which I can apply algorithms from machine learning domain. So I'll take a small example. Let's say we are looking at a 2x2 matrix. Okay, let's say we're looking at a 2x2 matrix. This is A1, A2, and say B1, B2. This is a 2x2 matrix. Okay, I want to compute, say, its maybe say determinant. I want to compute the determinant. Yeah, I want to compute the determinant of this matrix. Okay. Now, anybody can tell me what is the determinant of a 2x2 matrix? Anyone who knows how to compute the determinant? So this is nothing but A1, B2 minus A2, B1. Okay, so you can put it like this: A1, B2 minus A2, B1. So this is the determinant of this 2x2 matrix. Okay. Now it's well defined. This determinant is well defined. So if you give me any number, I can put in this 2x2 matrix. If I give you 4 numbers, I tell you what A1, A2, B1, B2 are. Would you be able to compute the determinant? Yes or no?
Yes.
Right? That makes sense, right? So there is a well-defined formula for it. Anything for any 2x2 matrix, you can now compute the determinant because there is a well-defined procedure, well-defined formula for it. Machine learning is used in those domains where there is no well-defined formula. As simple as that. You can say that if there is a task for which there is no fixed set of instructions for me to accomplish this task, that's where you will use machine learning. Let me give you some examples where you would use machine learning. See, this is one of those domains where you as a human are able to do it reliably. When I say reliably, you're not 100% accurate either. Okay. We want our machines to mimic human nature. So you as a human, you are able to do certain tasks. That too very reliably. Let's say you are 98 or 99% accurate all the time. So you as a human, you can do some tasks very reliably, but obviously there is no algorithm for it. Can you think of certain tasks like this? Can you think of some tasks which you do in your day-to-day life, which for which there is no explicit algorithm, but you are able to do it very reliably, and there is no algorithm known to the man or known to the world which can do it? Anything comes to mind? I can tell you thousands of tasks.
Weather,
Which one?
weather prediction.
Weather forecasting. Yeah, that is one of them. Okay, you can think of it like if I know the weather of the past few days, even then I cannot predict what is about to happen. Okay, but the idea of machine learning is if you collect enough data, okay, if you collect enough data, then perhaps you can predict or you can forecast the weather for the next few days to a reliable extent. I'm not saying you'll be 100% accurate, but to some extent, see, as a human also, by looking at the weather for the last few days, don't you think you can predict reliably? See, you obviously you will not be right 100% of the time, but you will still predict it reliably, right? There is some human experience involved. Okay, in this season, rain doesn't happen, or in a particular season, more rains are there. So things like that you can make use of to predict the weather to some extent. Think of stock market predictions. Okay, let me give you even easier tasks. Imagine I give you an image, and in this image there is an object. It could be an animal as well. You as a human can easily tell me, okay, what is the object or what is the animal in this image, or who is the human in this image? Okay. Do you think there is an algorithm for it which can tell you what is the object or like where the object is? Do you think there is a reliable algorithm for it? When I say reliable, there is a whole complete set of instructions which can always figure it out. See, when I told you about determinant, do you think in the universe of 2 cross 2 matrices, I can use this formula and I can get the determinant? Yes or no?
Yes.
But for an image, if I give you, you can actually predict incorrectly because that might be beyond your domain. I mean, you'll be able to locate where that object is, but you'll not be able to tell, okay, what specific animal it is. Does that make sense? See, I'm saying there are certain tasks for which there is no algorithm. However, you as a human are able to do it reliably. Okay. So for all those tasks where there is a pre-specified set of instructions, what we typically use is traditional programming. So for all those tasks where you have a pre-specified set of instructions, you use traditional programming. And for everything else, we use machine learning. Basically, where we cannot define what is the, you can say, clear set of instructions for implementing it. So I will try to be maybe a little more rigorous here. So if you look at the traditional programming paradigm, so when you are making your programs, you write a piece of code, right? So what you typically do is you write a piece of code which will work on an input, and you write the program for it. So this program runs on a machine on this given input, and what it generates is the output. Can I say this is like a block diagram for a traditional programming paradigm? Does that make sense? So your program runs on any given specified input and produces the output, right? Okay. Machine learning is a little different from it. In machine learning, what you do, you feed the input and you specify the output for it. And what the machine outputs is a program. And then this program, hopefully, it has learned how to get your input from the, how to get your output from the input. And once this program has learned enough, you can use this program for new inputs. And it can generate the reliable outputs that you need. Okay. That is what machine learning is. Now, I'll give you an example, okay? I'll probably make use of the same example of determinants. So imagine I did not know this formula, okay? Imagine I did not know this formula. I did not know this formula, okay? Let's say there is a person who knows how to compute determinants. So, or you can say there is a God. If you give it a 2 cross 2 matrix, it will compute the determinant for you. Or there is an oracle which can do it for you. So what you will do is you will tell me, you'll give me a matrix, let's say 2, 3, 1, 4. And what is the determinant for it? So there is a God which tells me the determinant for it without telling you the formula. Without telling you the formula. Okay. So what you will do is you will compute the determinant for it, which would be 8 minus 3 in this case, which is 5. Now I'm not telling you the formula. There is a God, you can imagine that. Okay, which computes this determinant and gives it to me. So what I will do is I will feed this input and the corresponding output to my machine in the hope that this program understands if somebody feeds me a 2 cross 2 input, I have to generate this value 5. Okay. Do you think one input output pair is going to be sufficient to learn that, okay, this 5 is actually the determinant? This 5 is generated through this formula.
No.
No, right? So you would have to feed it enough pairs of input output. So imagine I'm feeding in 1,000,000 pairs. I'm feeding 1,000,000 2 cross 2 matrices and the corresponding determinants. So you can think of it, this machine, as a child. Do you think that if I give 1,000,000, and I shouldn't say a child, but maybe a human, okay? So if I give in 1,000,000 2 cross 2 pairs and the corresponding determinants, do you think that a human can figure out what the determinant is? What the actual formula for determinant is? Yes or no?
No.
Cannot?
Yes, sir.
If I give you
Oh.
1,000,000 pairs
Okay.
as a human, you can, right?
Yeah.
Not 100% reliable. Like,
No, I'm saying it will not be 100% reliable, but don't you think that they will come up with a formula which should be very, very close to the determinant?
yes.
I'm going to give you 1,000,000 pairs. For every 2 cross 2 matrix, you will know the output. As a human, you can do it very reliably, right?
Yes.
So we will actually make a mathematical model. So if you think about it, this program is nothing but a mathematical model. It's going to be a mathematical function, which what it will do is you will give it some input and it will map it to the output. And this is the function that it is trying to learn. This is the function that it is trying to learn. Okay. So if you give it enough data, we can see if there was a fixed formula for it, machine learning algorithm will find it out. If you give it enough data, I'll show you that. If there is a specific function that you're trying to learn, if there is a specific function, it's a fixed function. I'll show you that. I'll prove you also that machine learning algorithms can figure it out to the dot. Okay, they'll be very precise. However, you need to give it enough data. Okay, that's one way to interpret it. Now, how they do that is done using some mathematical techniques that we will see. So I hope you have an understanding now where machine learning algorithms are used. So essentially what we want to do is we want to learn this formula. So if you think of weather forecasting, I want to learn this formula of weather forecasting. So how would you typically predict weather? I mean, let's say what is the temperature tomorrow? What factors would you consider in if you want to predict weather or say temperature of a particular day? What factors would you consider?
Humidity.
The intensity of
Humidity,
the
wind
humidity
speed,
level.
probably what time of the day it is, what is the specific hour,
speed.
minutes, and seconds. Okay, that will give you some additional details. Do you think that if I give you all these details, so if I tell you that, let's say, what is the humidity right now, what is the time of the day, which day it is, let's say, which month it is, which year it is. I mean, year may not be useful. But let's say, so I'm giving you some important features. You can think of wind speed and so on. And don't you think you can learn what the temperature is? Given that, I give you the data about, say, 1,000,000 days.
Yes.
So I'll give you a matrix where you have, so every row is 1 day. Okay, so this is day 1, this is day 2, this is day 3, and so on. For every day, you know what humidity is, you know what time it is, you know what day it is, and so on. and the final column is basically a temperature. So for every day, I'm telling you what the temperature is. Okay, for every day, I'm telling you, let's say the temperature is Y1, this is Y2, and so on. Now, don't you think that if I give you, for a new day, if I tell you what the humidity is, what the time is, what the day is, and so on, don't you think you can predict the temperature using this data? Yes or no? Does that make sense? I've given you so much, data. Don't you think you'll be able to figure out what the temperature is? Can you think of one simple algorithm which can help me predict the temperature? Simplest algorithm that comes to your mind. If I give you this data, how would you figure out what the temperature is? You have to tell me a reliable estimate. See, I'm not saying you will be 100% accurate, but you want to be very, very close. So what should be your prediction? In this case, like, how would you use it? If somebody gives you, okay, humidity is maybe say 8%, time is maybe say 6 a.m. in the morning. So I give you this time 6 a.m. A day is probably a Sunday, and so on. Okay, I give you all these details. How do you figure out the temperature from this data? Don't you think what you can do is a simple search? Can you search for the closest sample with respect to all these days? Do you think it is possible that you can search for the closest sample in this data set?
Mm-hmm.
Yes.
And whichever is the closest sample, I will look at its temperature and I can say that that is the predicted temperature.
Yes.
Simplest algorithm, right?
Yeah.
Okay. This is one of the machine learning algorithms called as k nearest neighbors. In this case, it is called as one nearest neighbor. Okay. Now, let's say if I'm going to use 3 of the closest samples. So instead of looking at one sample, I now look at 3 closest samples. So I have 3 outputs now, 3 temperatures for the 3 closest samples. Don't you think I can average it out across the 3 samples? If I want to be more precise, instead of looking at one sample, I look at 3 samples now. See, I'm not claiming 3 would be better than 1. I'm not claiming that. You have to test it. We will see how to test it as well, which value of the closest samples is the best. Is it 1 closest sample? Is it 3 closest samples? Is it 5? Is it 7? What is the number? We will see all those details. But I'm trying to tell you that a simple search is also one of the machine learning algorithms. Now, there are more complicated algorithms which we'll discuss with time. Okay. Even this is not the discussion about an algorithm. This is just to show you that a simple search can be helpful for predicting your temperatures. Okay. Now, I'll make it more precise where machine learning is to be used. So please keep these things in mind. This is super important. So machine learning is typically used in all those applications. So one point I have already raised, where your human expertise is like a black box. So you as a human can do a task very, very reliably. Okay. So what you want to do is, like, you have something in your head, right? When you are looking at an image and telling me, okay, who that person is. So your brain has some formula. Okay, your inbuilt connections in the neurons, they are able to tell you who that person is in this given image, but there is no algorithm for it. We want to find that function. We want to find that algorithm based on the data that we have collected. Okay. So this is where one of the areas where, so you can think of facial recognition, forecasting about stocks, weather. You can think about, okay, I'll give you one more example. Have you guys used autocomplete? So when you write your emails, when you write a piece of text, do you think that it autocompletes it for you? Have you seen that?
Yeah.
That is also one type of forecasting. So based on what you have written so far, very little information it needs, and it can actually tell reliably most of the times that what you're about to type next. And you also can tell me what you're about to type next, right? If I give you a short sentence or partial sentence. So that's where all of these machine learning algorithms are used. Okay. Now, the second scenario would be when the phenomenon is.
Sorry to cut you off. Like, machine learning is something that predict the data or predict the output as much as it can, but it can't be able to give a 100% of correct data.
Correct. And see,
Okay.
if you give it enough data, okay,
Mm-hmm.
let's say if the formula that you have, okay, if the formula that you have, even though you do not know it, the goal of machine learning is to figure out that formula, is to figure out that secret recipe through which the input and output pairs are related. So if there is a
Okay.
perfect formula which matches your input and the output, it will be able to figure it out.
Okay. So that formula finding is our job.
Yes, your formula finding is your job. Okay.
Okay.
So maybe I'll give you another small example just to illustrate this. So imagine that I give you this function x. Okay, a function on this x-axis. Let's say the function is, say, maybe 3x squared plus 6. Okay, this function is 3x squared plus 6. So I'm not going to tell you what this function is. Okay, I'm not going to tell you what this function is, 3x squared plus 6. What I will give you is, I'll give you the values of x, and I will tell you what is the function value at a particular value of x. So please listen to me very carefully. Look at this. So if I tell you that x is, say, 5, if you compute the value for 3x squared plus 6, okay, if x is 5, you compute the value for 3x plus squared plus 6, it will come out to be 81. Put x as 5, it will come out as 81. Okay, if I give you the value as 0, you'll get the value as 6. If I give you the value as 2, if you substitute in here, you'll get the value as 18. So do you think that for different values of x, I can give you different values of fx? Yes or no?
Yes.
Now, as a human, if I give it to you, don't you think that you can actually predict this function? How are x and fx related?
Yeah.
Yes or no?
Yes.
You
Yes.
can call it y also if fx is bothering you. Okay. Machine learning will uncover this function if your x and the fx are strictly related. See, I didn't tell you what 3x squared plus 6 is. It's the machine learning job to figure it out what 3x squared plus 6 is. Okay. And you will see that it will predict it very, very nicely.
Okay.
If there is a strong correlation between the input and the output, it will easily figure it out. But it is not necessary. Okay. It is not necessary that, so if the function had some random noise, imagine now if the function had some random noise. Okay. So maybe say this was 84, maybe say this was 6.5, maybe say this was 18.7. Do you think you can figure out 3x squared plus 6 now? Exactly 3x squared plus 6? Probably not, right?
Yes.
But will you still be very, very close to 3x squared plus 6? Maybe you figure out 2.99x squared plus 5.8. Don't you think you'll be reliably close to this? Does that make sense?
Yeah.
That is what the purpose of machine learning is.
Okay. Okay. So
Figure a function which is very close to it.
Okay,
To add
okay.
on over here, I would say, can we say that the simplest example for machine learning that we do also is when we are doing that logical aptitude test, we are given series and we find the next missing numbers. What we are doing, we are finding the pattern in that series and then computing the unknown.
That is one of the applications of ML. That is one of the things that machine learning can do. All to the point. Okay, I'm not saying that that's not one of the applications. So it's like, see, what she's saying is this: given a sequence of numbers, so you can think of it like maybe say the sales of a particular day. Okay, so maybe imagine if you are selling say 30 iPhones on day 1. Okay, this is the data on day 1. On the next day, you sell maybe say 28 phones. On the next day, maybe you sell 35. On the next day, you sell maybe 46. So given some number of days, your job is to predict, okay, what is going to happen on day 11 if you have the data up to day 10. If you have the data up to day 10, do you think can we figure out for day 11? Do you really know what the function is? How these values are related? No, right? That is hidden from you. I was giving you an example where the function is explicit so that you can understand it, what machine learning is going to do. In this case, basically in this case, the function is hidden. I want to uncover that function. If I can uncover that function, then I can predict it for any number of days in the future. Yes or no?
Yes.
Does that make sense?
Yes.
But do you think that the next set of values which is generated from see, I cannot claim that this value is generated from this last value or the values prior to it. How many values prior to it? I don't know that. This is so if I have enough data, I'm hoping that those relationships will be uncovered and the function would be learned. If I have enough data, now that's a catch. Okay. Now, how much data is sufficient? I cannot claim out. I mean, I cannot claim it right now, or I cannot tell you how much is sufficient right now. You need to tell me what the data set is. See, there might be a lot of noise in your data. So in those cases, machine learning will not be very accurate. So if you think about this kind of a data set, do you think it is, I mean, it will do a really good job? If I only provide you the sales numbers, don't you think you will need additional factors? For example, if it was raining or not.
Not this
Another
one.
thing.
My example was not this one. I was
Yeah.
saying with questions where there is a series of numbers, where there is a relation in those numbers. Right.
So see, it's the same thing. There is a hidden relationship. Okay, there is a hidden relationship here. You are talking about a specific example where there is a fixed pattern.
Yes, fixed pattern, right? Fixed pattern.
But do you think that in the real data you have fixed patterns? No, right? So our job is to find a function which mimics whatever patterns are there. Okay. Our goal is to come up with a fixed function. So a fixed function will not be suitable in those cases. That's what. So I'll tell you one of the areas where machine learning, I mean, it doesn't fail miserably, but it still fails to some extent, is actually time series forecasting. When there are a lot of hidden patterns in your data. There is not a fixed pattern. See, obviously, if there is a fixed pattern, machine learning will do a 100% accurate job. Let me tell you this. If you show it enough series. So for fixed patterns, it'll be able to figure it out. I'll show you for all these examples. Maybe for some of these examples, machine learning can uncover it very, very easily. However, in most real world data, it's not as simple as what you're thinking right now. There are so many factors which affect the sales. See, there are geopolitical factors, there are factors related to manufacturing, there are factors related to shipping and all those details. Am I having all those details in my sales forecasting data? No, right? I only have the numbers. So are these numbers sufficient to predict what is about to happen on the next day? Maybe not. So it will matter on what you give it in the input. It will also matter how reliable your input is. Okay, there are so many conditions for your machine learning algorithms to learn well. So we'll talk about those things in detail as we progress. Okay, does that make sense?
Yeah, sir. So basically, it won't be having a fixed pattern, but it will try to get the closest, the relation, that kind of
Correct.
thing, right? More the data we have, it will be more accurate.
Better your estimates.
Yeah. Okay.
Better your estimates.
Correct. Okay. All right. Yeah. Thank you.
All right. So this was so this is one of the applications where you would use machine learning. Another is when there is rapidly changing phenomenon. I have already spoken about this. So in time series forecasting, the phenomenon changes quite a lot. Weather forecasting, time series forecasting. You can think of maybe say sales forecasting, okay, of a particular product and so on. Okay. Another area where machine learning is super useful, where you have to do customizations or personalization. So I'll give you an example. Let's say you're looking at a web page from any e-commerce company. Okay. Maybe you're going to buy something from a website. There is something that you see when you open a page for a product, which is of suggestive nature. What is that? There is something that you see when you open a web page for any product. Let's say you're looking at a mobile phone. It shows you something on that web page, which is of suggestive nature. You might do this or you might go for it. What is that?
Suggestion of the products.
Suggestion of other products. Recommendations. Do you think our recommendations accurate?
No, not all the time. Like
not all the time, to some extent, right? You open YouTube videos, you see ads there. So YouTube is actually collecting your data to a significant level. Despite all that, do you think it is doing a good job when you look at those ads?
Not
not all the time, right? Not all the time. Not all the time. Okay. Some of the ads might be relevant, but you still skip it, right? Because you have to watch the video, not the ad, right? But I hope you get the point. So things that are of suggestive nature are also there in machine learning. So recommendation systems, recommendation engines, you'll see how to build them in this course. Okay, I mean with in the 7 modules that I have, you'll see those in one of those modules. You'll see how to build these machine learning models for recommendations.
Recommendation.
Okay, one more thing that you can understand is, like, if you go to a grocery store, why is it that like 2 products are kept next to each other? Any reasons? Do you think they are just placed randomly, or there is a logic behind it?
There is a
Connection that if a customer is inclined towards this product and the other product kept next to it, the customer might pick it up.
Spot on. The idea is this. See, what they have done is they have analyzed a lot of transactions in the past. That's your data. That's your input. Okay. So they know that they have prepared something called as frequent item sets. They know what set of products are bought frequently with each other. And on the basis of that information, they figure out, okay, what 2 products should be kept next to each other. What pair or what set of products should be kept next to each other. Now, there are so many things, like products are of complementary nature. Products are of, similar nature. Okay, see, sometimes products could be complementary. Sometimes product could be of similar nature. Sometimes products, what we say is, they are alternatives to each other. When I say similar, it means differently. Okay, so for example, if you talk about sugar, jaggery is a similar product. If you talk about complementary, salt is a similar product. If you talk about alternatives, then you might be looking at sugar from a particular brand, but I will show you alternative brands which also sell sugar. So there are so many factors when you build your good recommendation systems. Think of Netflix. When you open a movie, you see a lot of other suggestions, which are sometimes useful, sometimes not. So how do you build efficient like systems of suggestive nature? Okay, and I'll end it up with this one more idea. So machine learning can also be applied to those areas where human experts are not available. Okay, where human expertise is not even available. Okay, I'll give you a small example. So let's think of maybe say the sky. Okay, so you know that there are trillions of stars in the sky, literally trillions of stars, more than humans. Okay, obviously you cannot see these stars every day, but let me tell you, in our galaxy there are trillions of stars. Now, every day, do you know that some stars are born and some stars die? Are you aware of this fact? Just like humans die and humans are born,
no.
stars also die and stars are also born through Big
Okay.
Bang. Okay, through Big Bang. So there's literally trillions of stars which we cannot see from naked eye. I mean, not all of them from naked eye. Okay, so we have to use maybe say Hubble telescope or something like that, some instrument, right? So if I give you a picture where there are say so many entities, and so this is for day 1, and if I show you another picture which is of day 2, do you think as a human you can identify from trillions of entities which are very, very small dots? And the picture is actually really big. It's not that small image that you typically see on a computer. Okay, the picture is really, really big. Do you think you can easily identify where the stars are? Which stars have died and which stars have been born?
Not possible.
Not
It'll
possible even
take
from the
days.
naked eye, right? Not
Yeah.
possible even from the naked eye. I mean,
It'll take days to
it
count
will take
one
you
day.
millions of years just to identify.
Yeah.
Maybe you can do it in a couple of days. I'm not denying that. If there are significant changes, right? Now, the point that I'm trying to claim is there are certain areas. I'll give you maybe one more area where human expertise is not feasible at all. So, see, when we launch our satellites, so you know that ISRO launched Chandrayaan 2 or 3?
3.
3, right? So ISRO launched this satellite. They are going to a extraterrestrial entity, right? Maybe they're going to moon. Do you think they have ever been to moon before this? Or maybe let's say if you go to an extraterrestrial planet, let's say we go to Mars. Has anybody been to Mars? Do you know that? No, right? Not yet, as far as I know. Probably no satellite has reached, maybe let's say Jupiter. Okay, somebody has reached Mars. I am not aware of it. Okay, so you go to any extraterrestrial planet, you're going for the first time. Would you be aware of the terrain? Would you be aware of like how when you are landing, how what the surface is like? Is it marshy? Is it non-marshy and all that? Is it a sand dune kind of a thing, or like what it is? So when you go there, you are going there for some exploration, right? You'll be sending in robots, which will be navigating these unknown terrains. How do these robots know, like, how to traverse or how to navigate? It is unknown to us, right? What is that terrain? So we use machine learning. We actually make what we say is your robots try out different variations of terrains, and hopefully when they reach there, they can navigate through any kind of terrain. Okay, even though we don't know about like what is the terrain there, we try to simulate every possible scenario. I mean, obviously it might fail also, right, when it lands on the actual terrain. I'm not saying that, but we want to ensure that like when it reaches, it should be able to go and collect the data from it. Okay, this is like, these are some areas where human expertise is not even existing on extraterrestrial planets, right? You cannot even control the robot. Let me tell you this. When you are, I mean, obviously there might be astronauts there who can control the robot also, but let's say from the Earth, you cannot even control it. Okay. So these are some of the areas where machine learning is super useful. Now, depending on what type of task you are doing, there are different categories of machine learning tasks. So in machine learning, what we call these tasks as, there are two main paradigms, I should say. Okay, one is called as supervised learning, and the other one is called as unsupervised learning. And there is this third one, which is called as reinforcement learning. Now, reinforcement learning is not used for data science. I mean, it's not used for data science. So this is beyond your curriculum. This is beyond your curriculum. We'll be covering these two in detail. We'll be covering these two in detail. Now, I'll talk about what supervised learning is. And once supervised learning is done, then I'll show you how it is different from unsupervised learning. And both of them, they have a different set of tasks. Okay, that's why there are two categories in it. Okay, so let's first talk about what is supervised learning. Okay, let's first talk about supervised learning. Now, supervised learning is also called as teacher-based learning. This is also called as teacher-based learning. So it's like this. I'll give you this small example. So let's say that I'm trying to predict if someone has diabetes or not. Okay, I want to make a machine learning model where I want to predict if someone has diabetes or not. Can you tell me what factors would you consider? So see, okay, let's say you want to make a model where if somebody has diabetes or not for this. What you will do is, see, obviously there is no algorithm for it, right? You will reach out to a doctor. A doctor cannot probably give you the right formula also, because doctor, from his or her experience, they can tell you by looking at patient records, okay, this person is diabetic or probably not. Okay, but they cannot even tell you a formula for it. Okay, there is no such formula as such. So what you will do is you will probably go to a hospital. You will collect a lot of data. So this step is called as data elicitation. This is one step which you need not be bothered about, but I'm telling you, like, when you want to implement machine learning algorithms, there has to be this data, right? From where this data is coming in. So someone has to collect the data. Okay, that is called as data elicitation. Now, typically, any type of raw data is going to be, you can say, unstructured. So let me talk about what unstructured data is, just for from a small example. So when you go to say any hospital, what they will give you is probably digital records or hard copies. Okay, so basically it will be text. Okay, so they have given you these big files or big digital copies for every patient. So what they have given you is probably say records of 20,000 patients. So imagine each XI is a patient. So they have given you the records of these 20,000 patients. Okay. Now, from each record, what is it that you would like to extract? From each record, what is it that you would like to extract if you want to figure out if the person is diabetic or not?
Blood sugar level.
Blood sugar. Okay. So just to extract the blood sugar from the patient's report, don't you think you have to search?
True.
So in unstructured data, you require searching. Okay. And just to figure out where the blood sugar is, you have to match with blood sugar first. And whichever is the integer or the fractional quantity next to it, that will be the blood sugar. Okay. So raw text is basically unstructured. Unstructured meaning that you do not know where a particular entity exists. You have to search for it. Okay. So blood sugar is one. Can you comment on something else?
Age.
Age, maybe gender. Okay. What else? Maybe insulin, because you know that insulin is the hormone which inhibits blood sugar, which controls blood sugar, regulates blood sugar. Okay. What else?
Family history. Genetics.
Family history.
Yeah, genetics.
Genetics. Okay. So is this enough? I mean, a good set of features. I mean, obviously you can make more and more features, right? Okay. So what you're doing is you're creating these features, and these features will serve as your input. Okay? These features will serve as your input. Okay. And now what is the output? Your output is, in this case, your output, I'm going to label it as Y. Your output is whether a person is diabetic or not. Okay. Your output is whether a person is diabetic or not. Now, my question is this. When you are trying to work with any data and you are trying to apply maths on it, it has to be numbers, right? Yes or no? It has to be numbers. It cannot be text. Okay. When you are going to apply some mathematical functions on some numbers, okay, they have to be numbers. They cannot be text. But there are certain attributes like age, sorry, like gender, which might be text, like male or female, right? So we will see how to convert them to numbers. That is secondary right now. Okay. But let's imagine that if somebody is male, let's say that is 1, female, okay, somebody who is female, that is a 1, and male is a 0. Okay. So let's keep it that way. Now, if same thing, if somebody is having diabetic, somebody who is diabetic, it's a 1, otherwise it's a 0. Okay. Now, keep this in mind. So for every feature that you have extracted, okay, there is a number available. Okay, for every feature that you have extracted, there is a number available. Now, do you think that in the patient record, it will be mentioned that the person is diabetic or not? It will be, right?
Yes.
So you have collected these 20,000 records. Okay. Do you think that if I tell you for a new person, what is the blood sugar, what is the age, what is the gender, what is insulin, what is family history, would you be able to predict if the person is diabetic or not using these 20,000 records?
Yes.
This is what is supervised learning, what we have been discussing so far. Okay. So this is supervised learning. And why is this called as supervised? Because there is someone who's telling me what the actual value is. You can say it's a god, it's an oracle, it's a data collector who's telling me what the actual value is. Is it a 1 or a 0? So for every record, I know that is it a 1 or a 0. The actual value is known to me. And that's how machine learning algorithms are learning. They are trying to connect the input and the output. So in any supervised learning task, you will try to match, or you will try to map the input to the output. You'll try to map input to the output in some way. Okay. So input can be any number of features. Even you can predict multiple outputs also. It's not just one output. See, you may want to know if the person is suffering from any other disease also. Okay. Or you may want to know like how many days the person has left. Okay. Till he dies. Okay. So you can predict that also. If you have all these details stored, maybe we are doing this analysis of dead people. Okay, so I will know when they died, right? So when this data was taken, I will know after how many days the person died. So I can actually predict the death date of a person also using this data if I have those records. So the idea here is using these inputs, we try to predict the output. Now, time for some terminologies. Okay, so if you look at one row, this row is nothing but an individual here. So row is also called as a sample. It is also called as an instance. It is also called as an observation. It is also called, in this case, you can call it an individual also. Okay, so these are some synonyms which you will see, I mean, me using it, or you will see like when you are reading books or reading any blog, you will see people will use these synonyms for a sample, observation, and so on. Okay, if anything comes to mind, I'll mention it. There are so many synonyms for everything. Now, if you look at a column, right? Look at a column. So column is nothing but a feature. Okay, column is nothing but a feature. It's also called as a dimension. Okay, it's also called as an attribute. It's also called as a characteristic sometimes. It's also called as a variable. To be more precise, it is called as an independent variable. Okay, it's called as an independent variable. Okay, so these are some of the synonyms that you will see for your columns. Okay, and similarly for your output, there are again some values. It is also called as the target that you want to predict. Okay, it is also called as the dependent variable because it depends on your input variables. Okay, so these are also called as input variables or input features. You can call it as inputs also simply. Okay, so output is also called as a dependent variable. It depends on your input variables. Okay, these are some of the synonyms which people use. Okay, now if these terminologies are clear, let's see our first machine learning algorithm. Okay, our first supervised learning algorithm. Now, before I start with this, I'll give you one small, I mean, this is like a small bit of information. So imagine this, let's say you are a baby. Well, not you are a baby, I mean, as in, let's say there is a baby which is trying to learn if, or a person who's trying to learn if a person is diabetic or not. Okay. So if you show this first record to them, okay, if you show this first record to this person, as of now, you're not telling him that this person is diabetic. You're showing this first record to them. Okay. Typically, can you tell me how a person learns? Or how, let's say, how a baby learns? Okay. Typically, how a baby learns? Can you tell me? Like, let's say you are trying to make a baby learn colors. So, how would you make a baby learn colors? What would you do?
We'll show all the colors and then we'll say that, look, this is pink, this is red, this is green.
Correct. So basically, you'll show them some flashcards or maybe some card of a particular color. So you will show them the card. Okay, baby says boo boo. Okay, but then you'll say, no, this is not boo boo. Say this is green. So you're telling the exact color, right, to this baby. So the next time you show this card, hopefully the baby will say green. It will not say boo boo. So the idea is this: when you show every sample to you can say to your machine learning algorithm, what they will try to do. So most of these algorithms are iterative in nature. They try to learn iteratively, step after step. Okay. So one second. So they try to learn step after step. Like, so what they will say is they will try to predict something. And if their prediction is wrong, they will look at how much mistake they are making, and then they will try to update themselves. So the same way, like you told the baby, okay, this is green color, it's not boo-boo. So the baby will try to keep that in mind. Next time I see it, oh, it's a green. You show the baby next flashcard. You say, okay, so this is pink. Baby says green. No, this is not green, this is pink. So as you keep on showing these cards over and over many times, don't you think the baby to a reliable extent will be able to tell you the colors? Maybe say after a few days.
Yeah, it can.
Okay. So that's what machine learning is. If you show these, say, 20,000 flashcards to your baby after many, many times, okay, most algorithms are of that nature. So you have to show each sample many times, not just one time. Okay. So this process of iteratively updating is what makes a machine learning algorithm. Most of the machine learning algorithms are iterative in nature. Most of them, not everyone, not every algorithm, but most of them. You will see that. Okay. So what we have seen so far is these outputs, these actual values, they are the ones which tell us if we are going in the correct direction or if we are going in the wrong direction. So with the help of these outputs, we can figure out if our algorithm, if our learner is making a mistake or not. If they make a mistake, they'll update themselves. If they don't, they will look at the next sample and keep on doing it till the number of mistakes that they're making, it's minimized. Okay. And that's where you will say that, okay, your baby has learned enough, your learner has learned enough. And then you can show even newer flashcards to the baby, hopefully of the same colors. Okay. If you show it for a different color, which the baby has not seen before, it will still say one of the colors which it has seen before. Okay. So don't try to confuse the baby. It will still give you an output based on what it has seen. Okay. It cannot generalize beyond. That is another field of machine learning. We are not going to do that. Okay. So currently what we'll do is supervised learning. And supervised learning can also be divided into two baskets. So the first basket is where the outputs that you try to predict. So this categorization is done depending on the output that you're trying to predict. Depending on the output that you're trying to predict. Depending on the output that you're trying to predict. So if your output is real, you can say if your output is continuous by nature, you will call it as a regression task. There is a name for it. It's called as a regression task. If your output is discrete or categorical, you will call it as classification task. Okay, so these are some terminologies that you should know. These are some terminologies that you should know. Okay, let me give you some examples and you tell me if it's classification or regression. Imagine I'm trying to predict what is the object in the given image. What is it? Classification or regression?
Classification.
That is classification.
Classification, because the output would be discrete. Okay, it would be either object A or object B or object C or object D. Okay, can be many objects, but it would be one of the objects from your given set of objects. It's a discrete output. Okay, it cannot be anything between, say, you will not say object A 0.5. Okay, it cannot be between object A and B, right? Object 1 and 2 cannot be between that. Okay, think about rain forecasting. Not yes or no. Basically the amount of rain.
Regression.
Regression task. Because there, our purpose is not to figure out if it's raining or not. Our purpose is to figure out if it is raining, then how much it rains. Okay, so that becomes a regression task. Okay, let's say predicting what disease a person has. Let's say type of diabetes.
Classification.
Classification. So you, as you would know, there are three types of diabetes essentially. You might know type 1 and type 2. There is another type of diabetes which happens only for pregnant women, which is NMI. I don't know the full form, but I remember the short form for it. So there are three types of diabetes. So it's a classification task. It could be 1 or 2 or 3. It cannot be all the 3, or it cannot be two of them. It will be just one of it. Okay. Similarly, if you think about, let's say, predicting the death date or how many days are remaining, what is it?
That is regression.
Regression. Even though, see, when I'm saying predicting the death date is not a fraction, right? Date is an integer. You will represent it as an integer. So it's not a real value. But still, if you think about it, see, when I say it's a continuous value, the output lies on a number line. It can be any number along this line. When you say it's a classification task, the output is going to be one of the target categories. It cannot be beyond. See, it cannot be beyond your what we say is beyond the categories that you have seen in the data set. So there is like one huge difference. People get confused in regression and classification when regression outputs are integers. Okay, regression outputs can also be integers. Okay, So keep the difference in mind. Okay. In classification, the output will be one of the discrete categories that you have seen before. Regression can be the output can be integers, but it can be outside the range of the data set that you have seen before. Okay, like the date. Okay, or how many days a person has remaining. Okay, so maybe in your data set, if someone has the maximum, the person with the, you can say, the number of days remaining is 50, let's say that. Okay, say I will not say 50.5, I'll not say 50.3. I'm saying the number of days till the death of the person. So this is always an integer. Now in the data set you have seen 50, but the prediction can be a number higher than 50 or even smaller than the smallest number, right? It can be say 3 or it can be 2. Even if somebody has not, in the data set, if somebody doesn't have 2 in their outputs. Okay, so keep that in mind. Regression can be beyond the data set. Classification is always inside the data set. Okay, and it is discrete for sure. Regression is mostly continuous, but it can be beyond the range of the training data set also. Okay. Just one last terminology, and thereafter this, we will see how to implement some machine learning algorithms. We will see the simplest algorithm today. So, see, we are given a set of features to predict, right? So we are given, let's say, D features to predict. These are some D features, and we are trying to predict this output Y. Let's assume this output is, say, real, okay, or you can say continuous output. So we are doing regression. Okay. Now, somebody might give you just one input and try to predict the outcome Y. Okay. Somebody may give you more than one features. So when you are given one input, this is called as a univariate task. This is called as a univariate task because there is only one input variable. One input variable. Keep this in mind. If you are doing regression, if Y is real, you will call it as univariate regression. This is also sometimes called as simple regression. Okay. If you have more than one feature, which is this, if you have more than one feature, this is called as multivariate. So if you are doing regression, you will call it as multivariate regression. If you are doing classification, you will call it as multivariate classification. Okay. You have more than one feature, more than one input feature. Okay. Now you might be predicting more than one output. Okay, let's say you are predicting these k outputs. Okay, these are called as multi-output tasks. These are called as multi-output tasks. If you are trying to predict more than one output, now depending on what you are trying to predict, is it real or continuous, or sorry, real or discrete, you can name it accordingly. Okay, but if you have multiple outputs to predict, you will call it as a multi-output task. Okay, these are some of the terminologies. Let's start with the simplest example. Okay, I'll move to the implementation now, and we will see the first algorithm. Okay, we will see the first algorithm. Just a second. Sorry, if you prefer writing also, you can write to me in case you don't have a mic. Okay, so now if you want to write to me, let's say if you prefer writing, then you can write to this Sanatan Sukhija account. Okay, I'll open up the chat window here. Just give me a second. If you want to write, you can write to the Sanatan Sukhija account. So I'm just importing the necessary libraries. You guys have done pandas, numpy, and everything, right?
Yeah.
Okay, all right, great. Not plot length. Okay. So let's do a simple task. Okay, let's do a simple regression task. Okay, I'll do a simple regression task, and specifically we will do, say, univariate regression. Okay, specifically we'll do univariate regression. Okay, specifically we are doing univariate regression. So basically we have one input feature. Okay, we have one input feature. So you have one input feature. I'm calling this input feature as x1. Okay, so we have one input feature. Okay, maybe I'll use the data from you people. Okay, so let's do one thing. Let's maybe try to predict. Maybe I'll take age as the input, or not age, maybe say height as the input, and let's try to predict the weight. Okay, let's try to predict the weight. Okay, so weight is your output and height is your input. Okay,
Yes.
so from all those, all of you guys, you can probably share some of the data. Okay, I need just 5 individuals. See, because if the data is more, you would realize that the results would be more accurate. Okay, so what I'm going to do is I'm going to ask some of you to give me the data, or shall I just input some random numbers? What do you recommend? Shall I take real data or shall I just input some random numbers? Would you be comfortable in sharing your height and weight?
Yeah, minus 6.2.
Okay, so 6.2 would be, okay, let's say your height is in inches. So 6.2 would be 74 inches. Okay, and your weight is, say, in kilograms. You can tell me your weight.
Okay, that's the problem. Is 95.
Okay. That's why I said, if you're not comfortable, we can
Yeah,
actually.
that's fine. That's fine. Like that is nothing. 95 my weight is.
Okay, okay. So don't get embarrassed. Okay, see, I'll tell you, I'm 6'4". Okay, so I'm 76, but my weight is 127. Okay, so don't get embarrassed.
No, not embarrassing and all. Like I was just laughing at me, like in this lockdown and all.
That's fine. Okay. Yeah. Other people, please. Maybe I need data from a few other people.
5'4"
5'4". So 5'4" is 64. Yeah.
and the weight is 53.
53. Okay. You can be precise to the dot also. If you feel that, okay, it's 400 grams, we can put 53.4 or 52.8, whatever. Okay.
5 and 69, sir.
69. Okay. And weight.
5'8" and 69.
Oh, sorry. Can you repeat, please?
5'8" height, sir.
Okay, 68. Okay. And height. Sorry, weight.
Weight is 60, sir.
60. Okay. Anyone else? I just need one person. Okay. One more person.
68.
68 or 58?
68.
60 and
75.
75. Okay, great. I have some common data as well. Yes.
70 weight, not 60.
78 and
No, sir. That fourth data, sir.
oh, this is 78.
Weight is 70, sir.
Okay, weight is 70. My bad. Okay, weight is 70. Okay, all right. Okay, all right. So, okay, can you guys give me some like some more samples? Okay, let's say I'm going to use this data to make predictions. Okay, I'm going to use this data to make predictions. Okay, this is also called as a training set. Okay, give me now some data for which I can actually see if my algorithm is doing well or not. Okay, and I will be using this data to test, to validate the model performance. Okay, maybe 2-3 people can give me the weights and height.
5'6", 66,
5'6", okay,
and 60.
okay, all right. Maybe 2 more people.
63,
63 and
63, and 78.
okay, and one more.
5'8",
5'8", okay,
82.
82. Great. Okay, so this is the data. Now, obviously, do you see that only height is not sufficient? You require the gender also. Does that make sense?
Yes.
I mean, I see that the males are a little more on the heavier side. That is true, right? That is true. No need to be ashamed. Okay, I am not fit. See, I am the most obese person in this list. This is me. Okay. Anyways, let's try to use this data set to evaluate to make your predictions. Okay. So what we are going to do is we are going to use one of the algorithms which is called as k nearest neighbors. Okay. So when I'm going to use this k nearest neighbors, what I'm going to do is I'm going to find the closest sample to make my prediction. Okay, let's discuss. So my data is this. Okay, my data is this. Okay. Sorry, I need to maybe probably make it as a list. That will be quicker. Just give me a second. Shall I put it in a data frame so that you can see heights and weights being printed side by side? Will that be fine?
Yeah.
Okay, I'll just make it as a data frame. Okay, and the column values are, so you have these heights and weights. Okay. So let's call this as df. Okay, 1 second. So, I have passed two. Oh, sorry. Oh, my bad. It was two columns, right? It says one
Yeah.
column plus. Is there an entry missing anywhere? No, right? I don't see. Do you see any mistake in the syntax? Any brackets I'm missing or comma I'm missing?
Your list of tuples.
No, it's a list of lists that I have. It's a list of lists that I have. Every entry has two values. As far as I see it, I mean, it seems to be correct, right? Okay, any mistake that you see in a comma anywhere?
Inverted commas. Near height and width.
Yeah,
Yeah,
that's
that's
the mistake. Yeah, okay. So this is your data frame. Okay. All right. So this is your data frame. Now we are going to use these heights to predict the weights. Okay, let me just add, say this. Okay, just to demonstrate, okay, this is your feature and this is your output. Okay. All right. So we are going to use these inputs and outputs, I mean, just to make my predictions. So let me show you just a second. There is this question that I see in the chat. Okay, there is one person who has given the details. Okay, I'll just add this detail as well. Okay, this is 511 and 78. Okay, I'll add this in the script. So 511 is 69. Okay, and 78 kgs. Okay. Sorry, 511 would be 71. My bad. Okay. All right. So let's use this algorithm to make your predictions. Let me show you how this algorithm works. So first of all, this algorithm, this k nearest neighbors algorithm, this is present in this library called as sklearn or scikit-learn. Most machine learning algorithms that you will see will be present in this library, scikit-learn, scikit-learn. Okay, sklearn for short. So you'll see all these algorithms in sklearn. Okay. Now, in this library, there are certain classes. You can say there are certain directories or packages, sub-packages. Okay. And one of the packages is neighbors. And inside this neighbors, you have this k nearest neighbors. Okay, inside this, you have k nearest neighbors. Now, this algorithm has a special name in the implementation. Since we are doing regression, we call it as k neighbors regression. Okay, k neighbors regression. See, any model which does regression is called as a regressor. Any model which does classification is called as a classifier. So the name of this algorithm in the implementation is k neighbors regressor. Okay. So let us see how to implement this. So let's instantiate our model. Okay, just like how you instantiate a function. Okay, so I'm calling this function. Okay, creating an object of it. Okay, now I want to make my prediction with the help of some samples. Okay, don't you think this algorithm needs some other details? For example, how many people to look at to make a prediction? Yes or no?
Yes.
Okay, so those are called as number of neighbors, or n neighbors for short. Okay, n neighbors for short. Theoretically, this is nothing but equal to k. So what we are implementing, if you think about it, what we are implementing is, so currently, so this, the short form of this algorithm is KNN, k nearest neighbors. So currently what we are implementing is one nearest neighbors. If we say that we are going to look at one neighbor to make a prediction. Okay. Now, are you guys aware of what is Euclidean distance, what is Manhattan distance, cosine distance, and other details? How do you compute distance between two samples? Are you aware of those details?
No.
No.
Okay, so maybe I'll discuss that. Okay, so see, intuitively you can compute it in your head, and what you're doing is essentially computing Euclidean and Manhattan. I'll talk about it. Okay, maybe after this I'll talk about it. Okay, so what we are doing is we are going to find the closest sample. Okay, and now we are going to apply this model, the k nearest neighbor model, onto this data set that we have. So do you remember what should we feed to our machine? The input and output pairs. In the machine learning paradigm, what do we feed? The input and the output pairs. Okay. Now, please note that you are going to feed in this input and output pairs. Okay. So what is my input right now? Can somebody say?
DF of height.
DF of your height. Okay. So if you want to get your height, okay, let me just show you something. So you can actually write it like this. Okay. So do you know that in pandas, if you want to get the column names, you can simply say df.columns?
Yeah.
Okay. And if I want to get the first column name, I can write it like this. Does that make sense?
Yes.
Okay. And I want to get the details of this first column, so I can simply say df of this. Okay. Does this make sense? I prefer this syntax. See, because there is a space also here. So sometimes you might, I mean, if you forget to copy this, so you can simply write it like this also. Okay. Okay. This will also give you the same details. However, I prefer this syntax because I don't have to really worry about what is the column name. Okay. All right. So this is my input that you can see. Okay. This is your input. Now, I want you to focus on its shape. Okay. I want you to focus on its shape. So the shape of this input. Okay. What do you think the shape is? Anyone?
5 plus 1.
It would be 5 comma.
5.
I just want you to focus on this. It is 5 comma. Okay, it is not 5 comma 1. So what you have to do is any input that you are seeing, right? It has to be of the shape of number of samples, comma number of features. Okay. So how many samples are there?
5.
And how many features are there?
1.
1. So I have to reshape it into 5 comma 1. That is necessary. Output can be in the shape of number of samples, comma. Okay, output can be in the shape of this, but input cannot be of the shape of number of samples, comma, even if you are doing it with one feature. Keep this in mind. Okay, so please reshape this. So how you can reshape? See, you can apply this reshape function on a NumPy, you can say array. So how do I get the NumPy array from a data frame? Anybody knows? I have these values, right? I want to get the NumPy array format for it. You can simply type dot values. And this gives you a NumPy array. You can check the type of it. It is going to be a NumPy array. You can actually see it, it prints, right? Does that make sense? Okay, and on a NumPy array, there is a function called as reshape. Have you used this function before? Reshape?
Yes.
Okay, so you can reshape it into this 5 comma 1. Okay, you can reshape it into 5 comma 1, and this will now reshape it. And if you check the shape again, it will now print 5 comma 1. Does this make sense? Yes, people. Does this make sense?
Yes.
Okay, so you have to feed this. Otherwise, it will throw an error for you. It will say that please reshape your data. Okay, so the input is your this, and what is the output? I can simply say my output would be df of I can simply write it like this: df dot columns of 1. Make sense? Yes or no? These are your respective weights, right? Okay, this is your output. Okay.
So in my input, if I have two features,
Mhm.
not reshape it by default,
So if you have two features, it will already be of the shape of 5,2.
then in that case, I don't have to.
No need to reshape. No need to. This is explicitly for one feature.
One feature.
There's a problem with it. Yeah, there's a problem. In one feature, there comes to be a problem. Okay. All right. If you have two features, then you don't need to reshape. So the output is this. Okay. You don't even need to basically convert it to a NumPy array. This function can work with data frames also. Okay. So I'll just push everything above. Yeah, just a second. So that you guys remember.
So
Okay.
here,
Yes.
doing dot value and reshape, my input is changing into a array, right? NumPy array.
Yes, this is changing into a NumPy array. I said that your this function model dot fit can take NumPy array as well as a data frame.
So,
So if you want, see, if you want, you can write dot values here also. It will not have any problem.
but if I don't write, then also there's a no.
No
There's
problem. No problem. No problem. So this function can handle both. Okay, a data frame as well as a NumPy array, but the shape has to be consistent. Okay. All right. So the model is ready. What you have to do now is, see, the fit function, what it does in this case, it tries to make use of this data set for making a prediction. Now, to make a prediction from this model that you have trained, you can call it training if you want. Okay. So to make a prediction, the function is called as predict. Okay. And when you are predicting, please note that so if I'm predicting for one sample, okay, so give me the age of one person for which you want to predict. Sorry, the height of one person for which you want to predict. Let's say I want to predict for this person. We created this test set, right, to validate for this person 66. Okay, so I want to predict for this person 66. Okay, now I want to show you something. Please take note of this. This is your data set, by the way. Okay, can you tell me 66 is closer to which person?
The index number 3. In second one.
Or both are similar, right? 68 and 68.
So
but you have to look at the closest neighbor.
64 also, like
64 was closer.
I mean, 64 is closer, right? I mean, if you think about it. So I really don't know if it takes the negative preference or the positive preference, but just for simplicity's sake, let's see what are the results. But first, let's do it for say 71. Can you tell me which is closer to 71? Or maybe not 71, let's say 70.
68. Again, we have two values, 70 and
Okay, let's take maybe say 73. Okay, I want to resolve the ambiguities. Okay, first let's say 73, which is the closest?
74.
74.
So what will be the prediction?
95.
95. You see that the prediction comes out to be 95. Does that make sense? Okay. Now let's try to do it for 70. Okay. So which is the first closest sample to 70? I believe that it will give me this output 70 now. This 68 is closer, right? The very first sample, which is the closer. Yes or no? So when you're searching this data set, which was the first sample, which was the closest? 68, right? This one, not this other one. Even though they are at the same distance, which was the first sample that I encountered, which was the closest? Sample number at index 3, right? Does that make sense? Yes or no, people? So if I do it now, what should this predict? If I now predict it for 70, what should it predict? 70. 70. Hopefully 70, if I'm not wrong. Okay. Do you see that? Okay. Let's predict it for say 68. What do you think this will predict?
70.
70.
Okay. All right, let's predict it, maybe say for 75. What do you think it will predict?
95.
95. Okay. Now I hope you know how to resolve the ambiguity. Okay. So this is how your model makes your predictions. Okay. Now the question is,
Sir,
okay,
what will happen when the data are the same, sir?
so the very first point that would be chosen. The very first point would be chosen for making a prediction. See, this happened for 68 also, right? There are two 68s exactly. So which 68 was the first?
No, sir. If we want to get that 75 means what we have to do, sir?
Oh, why would you want to get the 75? See, your model should predict something, right? Okay, your model should predict something. Yes or no? I mean, you want to say the answer is 75 by making use of the second point. Then perhaps you need to change the code. You need to write your own function for your k nearest neighbors. Don't you think you can write it like by simply making a for loop and pick the sample which is coming in the last? Don't you think we can do it with a simple program? We can, right? Okay. It's just that you have to, modify the function if you want to pick the second one or the last one in a general case. So you have to modify it in that case. Okay. But this function typically takes the first. Okay. All right. Okay. Now see, you can even predict for multiple samples. So let's say I'm predicting for these two samples. Can you tell me what should be the outputs? So for 68, what is the output?
70.
20. And for 73, what is the output?
95.
95. Okay. You can see that the outputs are 70 and 95 respectively. Okay. So you can even pass, let's say, a test set. So I'll make a test set. Okay. So I'll just make a test set using these samples. Okay. Using these samples. Okay. I'll create a test set. Just give me a second. Okay. I'll create a test set. So these are the values. Okay. You can pass a dictionary also to this. Okay. You can pass a dictionary also to this. That will also work. I think if we would have passed a list of tuples, that would also work. Okay. A list of tuples would also do. I'm taking the same columns that I used earlier. Okay. So this is my test set. Let's call it df_test. Okay. So this is your df_test. Okay. Now, see, I want to make my predictions for all these people whose heights are there. Okay. I want to make my predictions for all these. So you can use this model.predict function. Okay. And pass this column of heights. So I'm going to pass this column from df_test. I'm going to pass this column of heights, which is df.columns of 0. So it will predict how many predictions. It will find how many predictions. Yes, people. If I pass this from this height, how many samples are there?
4.
4. So it will have 4 predictions now. Sorry, 1 second. I need to reshape it. Okay. Don't forget that. See, I'll show you the error. It says that reshape your data into this -1, which is 4, 1 essentially. Okay. So in this case, you take the values and reshape it into this -1, will also reshape it into 4, 1. You can write 4, 1 or -1, both will yield the same results. These are the 4 predictions. Let's save these values into, say, preds. So these are your predictions. Let me just print it. Okay, so these are predictions. I'll save these predictions next to the weights. Okay, so let's say that df of predicted weights is this. Let's say this spreads. Okay, my bad. This is df_test. So this is your data frame. My bad. We need to print data frame_test. So this is your data frame now. Okay. Now, can you see that the model is not doing a good job? Can you
Yes.
see that the model is not doing a good? Look at the prediction for the first person. It's 53. And the actual value is 60. So can you tell me how much is the error right now? How much is the mistake right now? 7. Which way you are considering? Are you doing? So typically we use this symbol as, okay, typically we use this symbol as, okay, one second. I'll just rename this. Okay, one second. Just give me a second. Okay, I'll just rename this. So you can rename any column also. So I'll just rename it like this.
1 second.
Yeah.
ಹೇಳೋಣ.
Go on.
ಹಾ,
Go on. Any questions?
ಹೌದಾ? ಹಾ.
Is anyone else able to hear him?
Yeah. I think he's on a phone call or something.
Oh, okay. All right.
Yeah.
Okay.
ಹೌದಾ, ಏನೈತೆ ಫೀಸಾ?
I'll mute
10 ಲಕ್ಷ. ಯಾವಾಗಿಂದ ಕಾಲೇಜ್ ಸ್ಟಾರ್ಟ್?
just a second. Okay, it didn't change. One second. You have to pass everything. Just a second. So I have to say in place is equal to true.
In place.
Instead of in place, you have like, yeah.
No, it's not changing the name. I don't know why. Just give me a second. Okay. Or I think I have to provide access. Yeah, I think this will change now. No, still not.
Rename columns equal to.
One second. Columns where? At what?
Rename. Before the dictionary that you have given, columns.
To give columns equal to. Okay, there is no access as such here.
Column, yeah.
Okay. So typically you will see like we will use this simple y hat for your predictions. Now, if I ask you what is the mistake right now, what would you say in the first sample?
7 units.
So which way you are taking, y minus y hat or y hat minus y?
Absolute.
Absolute.
Y minus y.
So please remember your mistakes. When you are saying you are making a mistake, you don't say that like you are, it's -7 or +7. You always say the mistake is 7, right? So we take the absolute values. Okay. So I want you to see what is the absolute error. Can I say that the absolute error is, okay, absolute error is this. Let's say I'm going to subtract the 2. So df of this df dot columns of 1 minus df of this df dot columns of 2. Okay, and I'll take the absolute of these two. I believe there is this absolute function. No. Okay, one thing I know is, okay, I'll use it like this. So these are the values, and in NumPy there is this function called as absolute that you can use. Okay, just a second. Give me a second, please. Give me a second. Okay, this is the first one. This is the second one. Okay, I believe that one of them is probably it's probably in a different shape. Okay. This is 0, 1, and 2, right?
Yeah.
Just a second. Let me print this again. This is it. Why does it say index 2 is out of bounds for access? Okay, just give me a second. It's raising an sorry, I'm using on DF. That's the problem. See, I'm using on DF. That's the problem.
Yes.
Yeah, that's the problem. And this is DF test. Okay, this is done. I wanted to focus on this DF underscore test right now. And these are your absolute errors. Okay. Now, if somebody asks you how well your k nearest neighbors is doing, what will you say on this data set?
Not
Can you give me a measure? Can you give me a measure which can tell me how well the model is doing? Can I count all the sum of
Yes.
absolute errors?
Yes.
Okay. And then I can make a claim that, okay, this is how badly this one nearest neighbor is doing. Does that make sense?
Yes.
This is one of the metrics to evaluate your regression models. So one of the evaluation metrics that you will see to evaluate your regression models is called as sum of absolute errors. Sum of absolute errors. Okay. This is one of the metrics which is quite popular. Okay. Now, to compute this, what you can do is, let me just first compute this. So what you will do is you take this DF of this absolute error, absolute underscore error. This is DF underscore test. And then you simply sum it up. Does this make sense?
yes.
Okay.
Yes.
There is one more. There are very. A large number of metrics are there. There is something called as mean absolute error. So do you think that if I want to know per sample how badly I am doing on an average, can I divide this number by the number of samples? That would be mean absolute error. Summing up all the errors, divide by 4. This is the number of samples, right, for this test data frame. Just see this. This is the number of samples for this test data frame, 4. So I am computing per average error. Okay. This is per sample absolute error. Okay. Okay. So this is this much. Whatever this number 61 is, you are dividing it by 4. Okay. Now think of it like this. So currently what I have done is I've taken the absolute error. Okay. Don't you think I can square the difference of weights and predicted and report that as the error? Yes or no?
Yes.
Okay, I can do that because in that case, error would also still be positive, right? Errors cannot be negative. I can square the error difference and call that as my squared error. So I'll just do it.
What is it you're gonna? Can
I'm
you
going to
repeat
square
once
the
again?
difference between weights and this predicted weights and actual weights. And that I will call it as squared error. See, one way to take the difference between two entities is you simply subtract them, take the absolute. Okay, this will ensure that your errors are positive. Okay, another idea to do it is subtract the difference and take the square. So this means that so why it is done, we will talk about it in detail. Why would you prefer this over the other? Or when you would prefer the former over the latter, we will talk about it. But this is also one of the evaluation metrics, okay, that we will compute. So whatever this number is, okay, whatever this number is, I'm going to simply square it up. Whatever this number is, you can simply do the square of it, and let's call it squared error. Let's call it squared error. Okay. So if you look at df underscore test, okay, the last column is your squared error. You have just squared each entity. And now you can look at other metrics, okay, which is say sum of squared errors. Okay, let's call it the third metric, which is sum of squared errors. Okay. So you can just square, you can sum up the squared errors. Okay. Sorry. Have I, is there any, okay, I'll just put it like this. Zero, 1, 2, 3, 4. What's the problem?
Hashtag.
You
Where
missed the
have-
hashtag above,
my bad,
commenting, yeah.
My bad, yeah, thank you. Okay, so this is your sum of squared errors. You can think of computing the mean squared error also. Okay, this would be your mean squared error. I'm just simply writing it as MSE. Okay, mean squared error. This is, by the way, the most popular metric. The mean squared error is, by the way, the most popular metric. We'll discuss in detail, okay, where to use what. We'll discuss in detail. Okay, so divide this number by your number of samples. Now, please note that you don't have to do all this. There are functions for it. Okay, there are functions for it. So what you have to do is you can use any of these functions. Okay, so in sklearn, in this library, there is a whole you can say list of functions that you can use as your evaluation metrics, and they are all present in this sklearn.metrics. So you will see regression metrics here, classification metrics here. Any function that you want to use is present here. Any. Okay. So let's say I want to use maybe say mean squared error. Okay, or maybe say mean absolute error. So you can call this function mean absolute error. Okay, let me show you this. I mean, there is a whole repository of functions in sklearn metrics. Okay, let me just show you the web page. Okay. Okay, so if you go to the left a little, you would see regression metrics. Do you see that on the left side? Regression metrics.
We do.
Okay, and then you can see there are so many of these metrics. So the first one is R2 score. We will talk about all these metrics, okay, as we progress. You will see mean absolute error. This is mean squared. There is no sum of absolute error and sum of squared errors. You can just multiply mean squared error with the number of samples. You will get sum of squared errors. If you multiply mean absolute error with the number of samples, you will get sum of absolute errors. Okay. So you have a lot of mean squared logarithmic error. You have mean absolute percentage error and so on. Okay. I mean, the list is huge. Okay. 13, 14 metrics that are available. So I'll just put this link here for you guys. Okay. So all the evaluation metrics can be accessed here. Okay. So I'll just make maybe a heading here for you guys. Okay. Okay. All right. Now let me show you how to use these functions. So for you to use these functions, you just have to provide the actual values and the predicted values. Okay. So if you talk about this mean absolute error, pass. So the input to this would be the actual values and then the predicted values. This is the format. So what are the actual values? Look at df_test. What are the actual values in which column?
Height and weight. So
No,
1 and 2.
Value in the sense your output, actual outputs.
Weights.
This is the column weights.
Weights, yeah.
And predicted is this y hat. Okay, so you provide this y and y hat, and they'll compute it for you. Okay, so I'm providing this y and y hat. So this
2 and 3.
in df_test, the column number is the first column, for the actual one. Okay, and the predicted one is the next one. Okay, so df_test. It might throw an error. I'm not sure though because of the reshaping. Okay,
You have double brackets or square brackets.
where? No, this is fine. Like where, as in we want square brackets.
Okay.
In this case, no. Okay. I believe this is showing an error probably because
df underscore
test. Yeah, my bad. Okay, so you can see that the value that we computed is the same. Do you see that mean absolute error? This is what we computed, right? 15.25. Does that make sense?
Here also like df.columns1 is df_test.columns1.
Sorry, actually the name of the columns is the same, right? That's why it is working. The name of the columns in both the data frames is the same. Up to 2. Okay, up to 0 and 1, it is the same. That's why it was working. Okay. Now I've corrected it. Okay, if you want to compute sum of absolute errors, you can just take this and multiply this number with the number of samples in this df.test. Okay, so multiply this number with the number of samples, and this will give you your sum of absolute errors. Okay, this will give you your sum of absolute errors. Okay, 61. It was 61, right? I hope. Okay, it was 61. Okay, you can check. Okay. So there are many functions. You can use mean squared error also. I'll just copy paste it and run it for you. Let's just run this. See, today is actually just the beginning. I just want to convey that, okay, we didn't discuss any maths today. Probably from tomorrow onwards, we'll discuss a lot of maths. So please be ready. Okay, please be ready. Don't get bogged down by the maths. Okay. So this is how you can compute all your metrics. Look at evaluation metrics, whatever you want to compute. Go there, look at the function. If it is not there, you can make your own. Okay, you can make your own. Define a function which will take y test and y hat, y actual and y hat, and just make your own function which will compute it for you. Okay. All right. Now I want you to focus on this. Okay. So we computed for this model. Okay. We computed with 1 nearest neighbors. Okay. Now I'm going to compute for 2 nearest neighbors. Okay, I'm going to compute for 2 nearest neighbors. So what this model will do, it will find the 2 nearest neighbors and then will average their actual values as your prediction. So I'll just give you one example. Okay. So now I have trained a model for 2 nearest neighbors. I want to make a prediction, say for the sample, say 66. Okay. Let's take, maybe say I'll do it for 71. Okay, just to avoid any confusions. So this is your data. Okay. Can you tell me what would be the output for, say, 71? Let's take 73 rather, okay, to avoid any confusions. Which are the 2 closest samples to 73?
95
74.
average.
These
74 and 76. Yeah.
74 and 76. So just add 95 and 127 and divide by 2. 95 and 127 and just divide by 2. And just you can divide this number by 2. That would be a prediction. Okay. So you'll see that this will also predict the same thing. Does that make sense? Is this clear?
Yes.
Okay. So I'm going to apply this model onto my test set. Okay. So I'm going to use model.predict on my df underscore test. The very first column is my your heights. So I'm going to use df underscore test dot columns of 0. Okay, I have to reshape it. So dot values dot reshape. Okay, and this will give me 4 predictions now. There are 4 samples. Each prediction is coming from the 2 nearest neighbors. So these are your predictions. Let's call it as spreads. Let's call it as spreads. Okay. Okay. Let's call it spreads 2 nearest neighbors. Okay. Now I'm going to compute maybe say the mean absolute error for this predictions of 2 nearest neighbors. So I'll compute the mean absolute error. Let's compute the mean absolute error with 2 predictions. Okay, this is your predictions. Okay, this comes out to be around 8. And what was for 1 nearest neighbor? 15.25. Which do you think is better? 1 nearest neighbor or 2 nearest neighbor?
2 nearest neighbor for sure.
Right, because it is much lower. Okay, so do you think that if I would have run it for 3 nearest neighbors or 4 nearest neighbors, this can even go down?
Yeah.
Right, and it can even go up. It's not necessary. It can even go up. Can you tell me what is the highest value of number of nearest neighbors possible?
4.
What is that? Is it 4 or something else? For a sample, when you are making a prediction, how many samples can you consider max?
The number of
N minus 1.
No, not 5n minus 1. You can consider what is n there.
The total
total
number
number
of
of
columns
samples.
we have.
Is
Sorry,
it total
rows.
rows, right? So what
Yeah,
is the
yeah.
number of rows that you consider for making a prediction in this data set?
We have 5
5.
rows.
So answer should be 5.
Yeah.
See, don't look at the test set. Okay, don't look at the test set. For each test set, you have to make a prediction using how many samples? in the maximum case, 5, right?
Yeah.
Okay, so the answer would be 5. It can go up to 5 nearest neighbors if you think about it. So it is not necessary that I mean 3 nearest neighbors will do better than 2 nearest neighbors. You can compute it. Okay, and we will also talk about, see, currently the way you are doing it, how you are computing the distance. You are basically doing this distance as this. I'll put it like this. If I give you a sample for prediction, let's say this one, okay, 73. How you are computing the distance? You are doing 73 minus 74, right? That is one way to do it. Yes or no?
Yes.
This is called as Manhattan distance. The absolute distance between 73 and 74, just like absolute error. Okay, that is called as Manhattan distance. We'll discuss this in detail. If you do 73 minus 74 whole square, and then you take the square root, which will be the same, by the way. Okay, this is called as Euclidean. Okay, we will discuss what is Euclidean, what is Manhattan, what is cosine, what is Minkowski. We'll discuss that tomorrow. So this is just to tell you that there are different ways to compute the distance. Okay, there are different ways to merge the predictions. Our objective is to find what value of the nearest neighbor along with what distance metric is the best. Okay, so we'll see that tomorrow. So our objective, yes, okay, our objective is to find the best model with the help of this k nearest neighbors, right? K can be anything. We can use different distance metrics, right? I'll show you there are ways to predict. Okay, let me just ask you this. I'll leave you with this. Okay, I'll just need 1 minute. Okay. Now my question is this. Currently, when we are making a prediction with 2 nearest neighbors, our output is coming from 95 and 127, right? Yes or no?
Yes.
Yes.
True.
Now, the question is this. Are you giving these 2 samples the same weight?
Yes, right now.
You are, right? You are saying that you are taking half the weight for this 95 and you're giving half the weight to this 127. Yes or no?
Yes.
You can interpret the average like this, right? Half weightage is given to 95 and half weightage is given to 127. So I can say that the closest neighbor is given the same weight and the second closest is also given the same weight. Don't you think I can weight them by distance?
Yes.
Does that make sense? You should give more weight to someone which is closer and less weight to that person which is far away. Would it yield a better result? I don't know. I have to check. In most cases, it does. That is called as weighted averaging. We will talk about how to do weighted averaging tomorrow. Okay. So all these details make a good algorithm. So when somebody asks you for k nearest neighbors, you need to know what type of averaging to do, what type of distance metric to choose, and how many nearest neighbors are doing the best job. We will discuss about all these 3 things in detail on a bigger data set, not a sample data set that I took from you guys.
Sure.
Okay. Okay. And there are a lot of other things that we have to discuss. Okay. So we'll complete this algorithm tomorrow. What I advise you guys is the following. When you come tomorrow, revise basic differentiation. Okay. How to differentiate, let's say, any given function. Some basic differentiation rules you should remember. Okay. So when you come for tomorrow, I'll tell you some rules from scratch also. However, like if you are already aware of basic calculus, just give it a read. That will be easier for me and it will save me a lot of time. So when you come tomorrow, maybe revise differentiation a bit.
Yeah.
Sanatan, some people,
tomorrow,
including me, are
Monday.
from commerce background.
Yeah, that's okay. I'll tell you, you don't need to worry about differentiation though. Okay. But if you are from, say, if you have done basic maths, probably, did you do any differentiation like in 10th or before 10th? No?
Yeah, in 12th we did, but I forgot it's long time.
It's okay. So that's why I said, I mean, probably give it a read for, say, 20 minutes. If you can't understand it, then I'll tell you, okay, these are the rules that you should remember. Okay. I'm just saying, I mean, I'll repeat it for sure. Okay. But in case if you know about some formulas, right, then you'll be able to understand it more during the session. Right? Yes or no? So I'm giving you a heads up. This is what I will use probably in tomorrow's session.
All right.
Okay. So I'm just letting you know, these are some of the things that you will see. The basic calculus, basic differentiation, not integration, basic differentiation. Okay. If there is anything advanced, I am not asking you to study that. So that's why this is something that people cover nowadays in 6th class. I'm being honest with you. Nowadays in 6th class, previously in our days, right, we used to cover it in 11th, 12th, or probably in 9th, 10th. Okay, so it has been a long time. I understand that. I'll cover it for sure. I'll tell you the basic rules. However, I request you to please go through it. Give 20 minutes, no more than 20 minutes. Okay.
Yeah.
Anything else that you want to know, if there is anything that you want to discuss? So all of you who have understood everything for the day can leave. If you have any questions, you can stay back and discuss.
I just want to ask, like, where do we find these notes and all this? Like, usually before with a mentor, we used to have a drive link and he'll post all those in there and then we'll access it.
So create a drive link for you guys right away.
Yeah.
Okay.
Like a pre-read.
I'll put some pre-reads also. Don't worry. For today's session, I don't recommend you to read anything on your own, because if you do that, there will be a lot of questions tomorrow.
Sure.
So let me finish, say, at least 2-3 sessions, and then I'll give you some reference material also. Okay.
Got it.
That will be easier for you to read after we have covered a significant portion.
Yeah.
See, we have covered bits and bits from here and there. Okay. There is no such one single, so I cannot share a single document or say multiple documents where you have everything.
Okay.
But if you go through all of them, you'll get confused. So let me finish a few sessions and then I'll put up everything, maybe a whole folder for reference material. I'll share multiple books also. Don't worry.
Is the class tomorrow or on Monday? So what is that? How is it?
I think it's on every day, right? Okay. I think it'll be next Monday, right?
Yes, Monday through Thursdays are sessions.
Monday and Thursday. Yeah, Monday till Thursdays. Yeah. So next Monday we'll meet.
Yeah. So from Monday to Thursday, like the previous mentors also, like this is going to be Monday to Friday. Sorry, Thursday.
Yeah, Monday to Thursday. Okay, Monday to Thursday. I have an announcement to make. I might not be there on Monday. I'm not sure. I might not be there on Monday. So if it is feasible for all of you to have a session on coming Friday, we can do that. Or we can do it tomorrow also. Now it is your call. Maybe the majority can decide and let me know. I'll interact with Google people, and whatever their decision is, I have to abide by that. So I'm not very sure I'll be there on Monday. So I'll send a notification to your coordinators and they'll convey to you if I'm not available. So in order to compensate that, if you want to do it tomorrow, in that case, I will not be there on Monday for sure. If say I'm available on Monday, then it would be just one more session, right?
We'll settle it up by tomorrow.
Okay, maybe
that's fine by me.
Let's meet on say Tuesday. Okay, and if you guys feel like that we should have it on Friday, okay, in that week, we can do that on Friday then, next week. Okay. If not, then I'll take one extra session from like in the latter half of the course.
Okay.
So whenever you guys feel like it, we can have the session during that time.
Sure.
Okay.
Sanatan, I don't know that it's a silly question or not, but can you give me a differentiation between this NLP and machine learning? Because this natural processing, what is that like? This NLP and machine learning both seems like same to me. So
no. So see, machine learning is a broad term. Okay. NLP is the domain where you only deal with text data, that is a special text data which is human readable.
Okay.
When I say human readable, what I mean by that is anything that is used to converse between humans. Any language that is used, maybe English, Hindi, Arabic, Japanese, Spanish, whatever all these languages are. If the data comes from these languages, then it is NLP, otherwise not.
So can I say that, like, for let's say Grammarly, or let's say like the prediction and all those, that's all an NLP.
Grammarly is a advanced NLP application.
Okay.
We will not be touching that far though.
Sure.
No, I'm just letting you know.
I just want to ask.
It's a really advanced application. Okay. So anything that relates with human readable text, the language that we use to interact. If the data is about that, then it is NLP. Otherwise, not.
Okay.
So if you can, NLP is like a subset of ML.
Okay, so NLP only deals with the text data, which is readable by the human.
Correct.
But machine learning is which is something far more better than that. Like it's a
You cannot
pro
call it
kind of
far
stuff.
more better because NLP is also ML, not the other way around.
Okay, okay,
Okay.
totally.
Typically, see, ML involves a lot more, not just dealing with text data. It involves image data sets, it involves speech data sets, audio data sets, it involves hybrid of, images and audio, right? Like videos. Okay, so NLP is typically, restricted to text.
Okay, okay.
Restricted to text only. That is too human readable.
Sure.
Okay. All right.
Yeah.
Anything else?
That's it.
Okay, I'll just share, create a link.
Yeah.
Give me a second. What is your batch? Batch name or batch title?
DSM4.
DSM4. Okay. Wait, it get created. Okay.
There.
So I'll create subfolders in it day-wise. Okay. So
Okay.
I'll put the links maybe after, in the next 5-10 minutes. Okay.
Okay.
So I'll just share this link and I'll put everything here in the next 5 minutes. I'll put it in the chat window. If you guys have a group, then you can perhaps share it on that group. Okay. You can maybe bookmark it.
Yeah, we were doing it.
All right, people. If anyone has any more questions, let me know. I'll put up everything in this folder in the next 5 minutes.
Sure, Sanatan. Yeah, and
I'll share a link as well where you can read about nearest neighbors. See, we have just touched the tip. Okay. So we'll be discussing whatever link I'll share, right? It will not have that much information which I'm about to tell you tomorrow. So wait for it. Okay. But if you want to give it a read beforehand, like, more than welcome. And we can discuss on that as well. I'll put a couple of reference links in a document there in this folder.
okay.
Anyone else has any other questions? I don't see any question here, neither on the other device. Okay, I'll end it then. So bye,
Yeah,
everyone.
Thank you, Sanatan.
Thank you, everyone. Bye-bye. Take care. And thank you for being interactive.
Yeah.
Interactive, okay.
Thank
In many batches, people are not very interactive. Okay.
Yeah, I know, like we all from working background, right? I know how it feels like, having a meeting and talking to someone else, like
Get to someone
nobody was
doesn't-
literally talking.
Yeah.
Yeah, I used to feel it every day.
Okay.
It feels
So
like anything.
let's all be interactive and
Yeah.
make the best, take the best. Okay, make the best out of what we have.
Sure, then. Yeah, have a good day then.
You too. Bye.